So today we are going to start the discussion of motion in two dimension. So actually motion in one dimension, the theory discussion is over and we have discussed a lot of problems as well, and I think you have done all the assignments and you could do all those assignments. So we are going to start motion in two dimension. So I would like to give it as 2D. I always write it as 2D. 2D means two dimension. What is the meaning of two dimension? So in the beginning of the lecture, like kinematics, I have taught you something like what is 1D, 2D, 3D, which means a point, a line, a plane, and space. The difference is, you know that, right? I guess. Okay. So then, what is a 2D? 2D means it's a motion in a plane, motion in a planar surface. So always you address the motion in two dimension. So always you remember, motion in 2D, always you address it as it is 2 into motion in 1D. Motion in one dimension. So what is the motion in one dimension? This is a motion in one dimension, or this is a motion along a straight line. This is a motion in one dimension. And what is this? This is also motion in one dimension. So you can always consider a two-dimensional motion means, look at this. So if I am moving here, this is a two-dimensional motion. If I am moving along one line, that is one dimension, then this line, two dimension. So 1 plus 1, 2. So like that only you remember. So motion in a plane, you can consider it that it is 2 into motion in one dimension. This is not accurately correct. This is not very accurate. But you just understand this is the simple formula that we have. Okay. So what is the use of this equation? Or what is the use of this formula? Our formula? Because you can address every two-dimensional motion problem as motion in one dimension. Why? Because what is 2 into motion in one dimension? It's very clear, because motion in one dimension, either it is constant velocity or uniform acceleration or non-uniform acceleration. Right now we have an idea, or right now we have a we have a clue that how to start the problem solving, right? Or you will be able to solve each and every problems in that. I think you are able to solve every problems in motion in one dimension. So motion in two dimension, we can use 2 into motion in one dimension. You can consider it as one motion along this one and one motion along this one. Okay, and then you will have a doubt. How do we differentiate motion in two dimension into two motion in one dimension? So for that we need vectors. Okay, for that we need vectors. So better first I would like to teach you what are the vectors and what are the properties of vectors and basic formulae and basic understanding about vectors. So that is like a part of our curriculum, part of our syllabus. So you need this, and in class 12th in maths you will study more about vectors. So that let it be there, but to understand motion in two dimensions. For example, the examples of motion in two dimensions. One is projectile motion, and second one is circular motion. Third one, relative motion in two dimensions. For all these things, to understand all these things, you need vectors. Okay, so I think you must have heard the word vector and scalar. So you must have heard vector, scalar. So what are vectors and what are scalar quantities? So let's start the discussion from there and then we will move on. Okay, this is just an introduction video. I think now you got what we are going to discuss, and the vector you must have heard, and how do we represent a vector? So let's talk about vectors. Like how do we represent a vector? Suppose this is a vector A, then we represent vector like this, vector A. Okay, this is what is vector A. So this is a vector. Okay, and let me explain what are vectors first of all, and then we will move on. Okay, so we will see in the next video. Thank you.